Welcome to the deep dive. Today we're doing something a little different. We're going to take an almost surgical look at a single line of code.
Just one line.
Yeah, from a blog post called Notes on Haskell Programming, Part 31.
Mm-hmm.
And our mission here isn't just about understanding a bit of Haskell. It's about seeing how, pure foundational math gets engineered directly into something really practical.
Something we all use every day.
Exactly.
Mm-hmm.
We're diving into the Haskell library optparse-applicative,
Right.
which is what programmers use to build command line interface programs, CLIs.
So if you've ever typed something like version or -f in your terminal, a library like this is probably what's running the show.
And the specific puzzle is fascinating. It's hidden in a line of code meant to add that universal help flag.
The help flag.
Yeah, it's a wonderful example of functional programming elegance. The real question is, how do you inject a standard feature like showing help text and then just stopping into a program's logic,
Right.
but then make that whole mechanism completely disappear when it isn't needed?
So it's there, but it's not there. Exactly. And the function at the heart of this is called helper. The source code shows it in this context. Parser, empty helper.
Okay.
And this deep dive is really about why those three parts, empty, that operator, and helper, come together so perfectly. It's the practical application of a really abstract idea.
Yeah. Okay, let's unpack this. I think we should start with the practical job. That seems like the easiest way in. What does helper actually do for the programmer?
Sure.
The source material says it's a custom built-in wrapped function. In the world of CLIs, we all have these expectations, right? You type HH or help.
Yeah.
And you expect a usage guide to pop up and the program to just stop.
Right. It shouldn't continue running.
Exactly. And the helper function just automates all of that. It saves the programmer from writing that same boilerplate code over and over again.
It really is like an automatic safety valve for your command line program. And if you look at what the source says helper contains, you see it's injecting some very specific metadata into the parser.
The standard stuff.
The standard stuff, yeah. Things like long help, short H, and then the actual text, help, show this help text. So at its core, helper is providing a parser that knows exactly what to do when it sees those flags.
It carries the instructions.
It carries the instructions for showing the help message.
And this is where, for me, the first really intriguing comment from the source comes in. It describes this as a hidden helper option, which always fails.
That's a crucial phrase.
What seems counterintuitive, right? A failure.
It is. But it's not failing like a crash. It fails in the sense that it deliberately doesn't produce a useful value for the main program to continue.
It's a dead end.
It's a planned dead end, a dedicated failure state that triggers a side effect showing the help text, and then it just cleanly exits. It's a form of functional short-circuiting.
Okay, I see. So if a user types help, the parser goes, I recognize this, shows the text, and then just stops the whole machine.
Precisely. It fulfills its duty by not passing control back to the rest of the application. And that's the first half of the puzzle, the desired failure path.
But then there's the other path, the successful path. What happens when the user gives valid arguments and doesn't ask for help?
Right.
The helper mechanism, even though it's technically part of the parser chain, has to become functionally invisible. It can't change anything.
And that need for functional invisibility is what leads us straight to the type signature.
Okay. This is the parser bit.
This is the parser bit. The source really highlights this technical detail. The helper function doesn't return a simple value, like a string. It returns a parser container that itself holds a function.
It's a function of type A.
Yes, and that's the absolute key to the whole thing.
So what does that mean?
It's a promise. It says, I am a function that takes some input of type A, and I will produce an output of the exact same type A.
No changes.
No changes to the type. And in our parsing world, that input, A, is the result from the main parser, the program's configuration, and the output A has to be the final configuration.
So if the main parser's result has to pass through completely unmodified, what's the only mathematical thing that can guarantee the output is identical to the input?
And now we step out of programming just for a second and into pure math.
Okay.
We're talking about the identity function.
The identity function.
It's the concept of functional neutrality. Think of it like the number 1 in multiplication. You can multiply any number by 1 and the number stays the same.
Okay, that's a great analogy.
Or, it's like the neutral wire in an electrical circuit. It's essential for the circuit to work, but it doesn't change the voltage. It just completes the path.
I like that. It's a transparent pane of glass you have to look through, but it doesn't distort the image at all. It is the very definition of no effect.
Exactly.
So let's connect the two paths back together.
Yeah.
Helper is this single thing handling two completely separate outcomes.
Right.
So outcome one,
Yeah.
the failure. The user types H.
Yeah.
The parser recognizes the metadata inside helper. It hits that always fail state, shows the help text, and the program halts. The function inside is never even used.
Correct. The identity function never gets applied.
And then outcome two, success. The user does not provide any help flags. So the helper parser successfully resolves, and what it produces is the identity function, A, which, because of that operator, is then immediately applied to whatever the main parser came up with.
And this is where the elegance just shines. Your main parser gives you your configuration, let's call it A. The identity function then takes A as its argument and just returns A.
The whole mechanism was there. It had the potential to stop the entire program, but when it's not needed, it applies a function that mathematically guarantees nothing changes.
It's beautiful, isn't it?
It is, but hang on, let me play the skeptic for a second.
Please do.
If the only two options are exit the program or do nothing, why bother with wrapping a function at all? Why not just have the success path of helper yield? Well, nothing. Why the extra complexity of the identity function?
That is a fantastic question, and it gets to the very heart of good library design.
Oh.
The optparse-applicative library is built on a mathematical structure called an applicative functor, and that means its operators, like array, have to work in a consistent, uniform way.
A rule they can't break.
A rule they can't break. The operator is built with the expectation that one side will always provide a function to apply to the other side's value. Always.
Ah.
If the library had to constantly check, did this optional parser give me a function or a value or maybe nothing at all? The whole internal logic would become a messy pile of if statements. It would lose its functional purity.
So by making sure helper always resolves to a function,
The identity function, in the success case.
the library's pattern never has to break. It keeps the core logic simple and clean.
The identity function is the perfect unit for function composition when the desired change is zero change. It's not a clever trick. It's a necessary placeholder that makes the whole system elegant and robust.
You know, it's interesting where we found this particular deep dive. It's from the blog of someone who calls themselves an old software plumber, Ang, over at kianmeng.org.
A software plumber? I love that.
It's perfect, right? It perfectly captures the spirit of this discovery.
Totally. Because if you look at the author's blog, they're not just a Haskell specialist. The range of topics is just huge.
Yeah, I saw that.
Haskell, Python, Go, Rust. But then also these deep dives into gardening, fish keeping, dieting, photography.
Right.
It makes you realize this is someone who applies a coherent set of problem-solving principles across completely different domains.
It's the same mindset.
It's the same mindset. A good plumber has to understand fluid dynamics and pressure, whether they're working with copper or PVC. And in the same way, the author's spotting and using the identity function here shows they're not just writing syntax, they're applying fundamental portable logic.
It really reinforces that idea that if you understand the abstract concepts, the math, the structures, you have a language that's universal.
Yeah.
It helps you design an elegant CLI in Haskell, and it probably helps you figure out the best filter system for a fish tank. The elegance of Apani applies anywhere you need neutrality or transparency. So, to summarize our deep dive then, we started with a simple, practical need. Adding a help flag in a Haskell CLI using the helper function.
Right.
We learned it's designed for two outcomes, either failure and exit if the help flags are there, or total functional transparency if they're not. And that transparency is achieved by wrapping the pure mathematical identity function, AA, inside the parser. When it's not needed, this function is applied to the main result, guaranteeing the outcome is mathematically unchanged.
It is quite literally the most elegant way to make a piece of code disappear when it's not on stage.
And that connection between the abstract needs of library design and the concrete needs of a command line tool, that's the real lesson.
It is, and it raises a really interesting question for you, the listener, to think about long after we're done here.
Yep.
How many other crucial standard software features things we rely on every single minute, like how default configuration values are handled, or no-op commands in a complex pipeline, or even error handling fallbacks? How many of those are implicitly relying on these simple, universal mathematical properties?
Even if they're not explicitly called identity functions in other languages.
Exactly. If you look closely enough at any piece of really robust software, I guarantee you'll find that functional neutrality is the invisible scaffolding holding the whole structure up.